All right. Well, it is wonderful to see that we're connecting from all over the world. I am going to say good morning once again. It is good morning in Austin, Texas, but we are well aware that it is afternoon, evening, or even night all over the world. So my name is Masha Pradanovic. I'm professor, associate department chair, and graduate admissions chair in Hildebrand Department of Petroleum and Geosystems Engineering. And I have with me Doctors Ravi Kumar and Dr. Stagel. They will briefly present on their research, but let them say good morning as well. So if you would unmute yourself and just briefly introduce, that'd be great.
Great. Thanks, Masha. My name is Arvind Ravikumar. I'm an assistant professor in the Petroleum Engineering Department, and I'm very happy to be here with you today to talk about some of the work that we're doing here and what you all should apply to UT Austin.
Yeah.
Thanks, Masha. Good morning, everyone. My name is Hugh Daigle. I'm an associate professor here in the department, and excited to see you all here and share some information about what we do.
There we go. And Dr. Daigle is also director of the center. Would you mind briefly saying what center is?
Yes, I am the director of the Center for Subsurface Energy and the Environment, which is a research unit that is dedicated to all things subsurface energy, which we're very proud of the good work we do here.
There we go. And I will later on I wanted to point that out is because I will invite you to follow webinars that are regularly organized by the center. So what you see here is my contact information as well as contact information of Dr. Sepernori, who is the graduate advisor, and he kind of decides what coursework you take and all that type of stuff once you enter the department. Dr. Balhoff, who is the department chair, as well as Amy Stewart, graduate program coordinator. Most of the time when you contact either Amy or PGE graduate office, you're actually corresponding with Amy. She could not be with us today because of a different appointment. She had to be there, but again, she is basically the person responding to most of your emails. So without further ado, I will just briefly move along and tell us our agenda today. So if Dr. Stagel and Ravi Kumar don't mind, I will first kind of give a broad overview of UT, University of Texas, Cockrell School of Engineering at UT, as well as our department. And then after that, and just briefly do a broad overview of the research done at the university. And here we have Drs. Daigle and Ravi Kumar basically joining us just to give an example of research done at the university. And then after that, we will move on to the requirements and any questions you might have. I will limit those to the application and where to find more information. But I'm happy to answer any detailed questions you have, and probably have too many slides on the topic. So I will stop at some point and just let you ask the question. Now, this session is being recorded. What that means, and we will actually post it later on a YouTube webpage. So if you don't want your face to show up, then please never get the camera on, but you are very welcome. This is just a regular Zoom meeting, so you can turn on your camera if you want to when we are having a discussion later. Also, you can simply post questions in chat. So all of those options are open. Just again, do note that this will be posted online. So without further ado, maybe you have visited, maybe you have not. So I'm here to introduce University of Texas a little bit. It is a very large public research institution in the United States. It was established in 1883. So it is over 140 years old. And it has large in the United States is the order of 51,000 students. So it's the top for a large schools in the United States. You probably know where to find the base website with a lot of general information. You will see both this orange color all over the place, as well as the animal longhorn that is basically the mascot of the university. The real mascot, called Bevo, is actually alive and shows up at football games. Now, that is just like where the signage comes from, so that you know. speaking of American football, it is a very, very popular thing to follow in the United States. My personal joke is that's not really football. The actual football played with feet is called soccer in the United States, but it is popular nevertheless. You can see a very large stadium here that we have in the University of Texas. So it fits a whole lot of people. And again, it's a favorite thing for students to go and enjoy the games. I would say, though, that football might be a massively followed event, but we have outstanding sports at the University of Texas and that you might or might not know about. So I will just spend one slide pointing out that we have outstanding swimming, track and field, volleyball and basketball teams. And actually, if there were at the recent Olympics 30 UT Austin affiliates. By that, I mean students and alumni who participated in 2024 Paris Olympics. They represented their own countries. So basically, they represented 14 countries all over the world, and there was 8 medals total won by them. One of them, Tara Davis-Woodhull, is for long jump gold medal is shown here in the picture. We also have the #1 women volleyball team, and they won championships in the United States in 2023 and 2022. And yes, we're hoping for 2024 again. That said, yes, we have outstanding sports, but #1 is our petroleum engineering graduate program. And I'm going to talk about that a little bit more as we go along. Now, engineering school, to kind of go down, we are in Central Texas before I move on that. And there is a lot of popular imagery of Texas in the movies. And often it kind of shows some dust bowl or or a desert. And I would like to counter that is that we're actually not in the desert in Central Texas. In May and April, we have a beautiful wildflower show that you see a picture of here in the top corner. This is the landscape is dominated by karst, and there is a lot of karst hydrology features. One of them being Barton Springs pool here shown in Austin. It is a very large pool with a small dam that fills up an area that is on the order of 2 to 3 large swimming, Olympic-sized swimming pools, and it has a natural bottom. The springs are coming out of 4 springs with pretty high in volume are coming out from a fault, Barton Springs fault, and that fills up the pool, and that is a very popular place to go to in summer. So we have water, we're not a desert. That said, it does get hot. Another karst feature is a little outside Austin is Natural Bridge Caverns. And then there is some granite formations such as the Enchanted Rock shown here that are also about an hour and a half outside Austin. So just some imagery for you. And in terms of food, we're famous for barbecue breakfast tacos. That is part of Tex-Mex mix of food, and margaritas. So to get back to the university, Cockrell School of Engineering is basically always in top 10 engineering schools in the United States. And that is per US News and Reports. In 2024, in particular, we were #8. This ranking goes up and down slightly, but again, we're top 10. And we're top 10 because out of 7 departments that have 6,000 undergraduates and about 2,300 graduate students, we have a number of programs. Here there's 12 listed that are in the top. So #1, Petroleum Engineering Department and program, #3, Environmental Engineering, #5, Chemical Engineering, and so forth. So all of that brings the excellence to the education. And there's a lot of highly awarded faculty. John Godunoff, rest in peace, he died recently, won 2019 Nobel Prize in Chemistry. And here you can see him getting the Presidential Award from President Obama as well. Now, UT PGE, PGE, by now you know, I refer to as Petroleum and Geosystems Engineering Department. offers bachelor's in petroleum and geosystems engineering. So we are way broader than petroleum only. We also offer master's and PhD in petroleum engineering, and have just gotten our master's in earth energy engineering, or triple E, that has been approved and will start in fall 2025. We have 400 undergraduates and 150 graduate students. We have 23 plus faculty. Some are tenure track, but we also have some teaching faculty. Out of them, 16 are SP distinguished members and 5 are National Academy of Engineering members. We have large research funding secured yearly. That number goes up and down because we continuously apply for grants. In terms of rankings, back to the rankings but now for the department, we are either number 1 or number 2 continuously since 2017 in undergraduate. And in graduate ranking, we have been number 1 since 2003, which is quite amazing. And this is based on the peer assessment of other departments. In the world, we have been ranked by Quacquarelli Simons number 1 for the past 2 years and number 2 before that. And this is surveying 1,500 plus institutions. Our faculty list is pretty long. Here, there's a list of everybody. And as I said, I have 2 other faculty with me to present on their research. So I'm not going to further belabor, but you are invited to go to individual faculty web pages to introduce yourselves to what they do. And I will point out those resources as we go along. In terms of research areas, we have traditional oil and gas research areas, but we are really both subsurface and above surface research at this point. A lot of subsurface applications are conventional and unconventional oil and gas, methane hydrates, geothermal, carbon capture, utilization and storage, critical mineral extraction, hydrogen and hydrogen storage, methane emissions, and what we call fundamental processes that are basically a building block, or studying of which is the building block for all of the above. In terms of technical disciplines, again, we have traditional drilling, production, reservoir engineering, formation evaluation, but then also petrophysics. Data analytics is, of course, a big and growing one. Geomechanics and rock mechanics, geology, geochemistry, sustainability, knowledge transfer. So we are big on teaching as well, and geophysics. All of these are studied with a varied set of tools. So basically, we do represent all 4 pillars of science, that is experiments, theory, simulation, as well as data science. Now, one thing that I'd like to point out, since big data is a lot in the news these days, is that big data is everywhere, but data has always been big in subsurface engineering. So from rock physics to drilling operations to data analytics, we do have a lot of big data research. Here are just some examples of the labs that have large data that they process. Van Oort Lab, their research programs are RAPID and CODA, Haidari Lab on multi-scale rock physics, or Dr. Perch and Dr. Foster, which is AI and direct. We do have, in addition to traditional oil and gas disciplines, we have a lot of sustainability. And here are some project examples, such as Dr. DiCarlo on decreasing methane emissions. Dr. Daigle will tell you in a moment on his research. Here, there's one example mentioned on reducing the amount of water currently being used in oil and gas operations, or Dr. Sharma making pipelines safer. Dr. Ravi Kumar will tell you more on his emissions modeling in a bit. And Dr. Song has a growing research program on rare earth metals and recovery, which of course is essential to have in batteries and for energy sustainability. This is a very good point for me to stop. I'm going to stop sharing my slides.
All right, so I just have a few slides here introducing some of the work that I do. I do a combination of laboratory work and field work, and also some computational work that's a little bit less of what we do right now. But here's some, just images of, from the past few years of cool things that we've done, including, cruise on a research vessel to collect seismic data. You're working with some nanoparticles and some other cool stuff. So let me continue on here. So right now, my research focuses on 4 different areas. We are looking at gas hydrates, both as kind of a resource and also kind of on the scientific side as a geohazard and looking at their role in the global carbon cycle. We have some work on nanotechnology right now, using nanoparticles to stabilize foams and also to treat produced water to remove oil from it. I do fundamental petrophysical research, including a lot of use of nuclear magnetic resonance, for characterizing the pore system of rocks, and also looking at different multi-phase flow properties of rocks. And then we're getting more into decarbonization, as are many people, and this includes some work on subsurface hydrogen storage, and then a new research initiative on carbon management that we're trying to get going. So here's some examples of what we do with gas hydrates. So for those of you who don't know, gas hydrates are these ice-like compounds. They're made of water molecules that are arranged around a low molecular weight gas molecule. We call it a guest molecule. And the most abundant naturally occurring ones have methane as their guest molecule. So they form these hydrates that look like ice, but you can light it on fire, which is pretty cool. And if we look at the global resource potential, this is called the hydrate resource pyramid. We're looking at how much gas in place we think there are in gas hydrates around the world. And, when you look at these numbers, it's, many, thousands of trillions of cubic feet of methane potentially recoverable. So there's a lot of work around the world being done to understand those. A lot of my work focuses on characterizing gas emissions from naturally occurring gas hydrates. So here's an example of some methane bubbles coming out of the seafloor, which may or may not be from hydrates. But we've done some work. This is an example from offshore Svalbard up in the Arctic. I actually have a student leaving today to go on a research cruise up there for a couple of weeks with some colleagues at a Norwegian university. But really understanding, how these gas chimneys form the sediment and how they lead to these, bubble columns that we can detect in the water, and how it's related to, the presence of hydrate and gas and fractures. Here's an example of some seismic data we collected offshore North Carolina, looking at, where there's hydrate, where there's gas. Here's a salt diapir, so understanding the whole dynamic hydrate system there. I took 2 graduate students and an undergraduate out with me for a 32-day research cruise on the Marcus G. Langseth, which is pictured here, where we collected cores and seismic. So we have a lot of fun doing this. It's a really cool area, and so a lot of kind of wide open science questions still remain.
I am still upset that I couldn't go.
Yeah, next time. I may be sending somebody out again this summer. I don't think I'm going, but we may have another opportunity to go back out. On the nanotechnology side, so nanoparticles are really cool. They're very small and they have a very high surface area. And these are some images of some of the silica nanoparticles we work with there. You can see this is a 40 nanometer scale bar. So we have a nice transmission electron microscope here at the Texas Materials Institute that we can use to take really cool pictures of very small things. What we do is we graft various organic polymers onto the surface of these nanoparticles to modify the surface chemistry, and that allows us to do all kinds of cool things. For example, we can stabilize emulsions with them. We've done a lot of work understanding how the emulsions get stabilized and how the surface chemistry of the nanoparticles allows them to remain stable. We've worked on stabilizing foams. So these are CO2 foams at high pressure, high temperature, high salinity, using different types of surface coating. I think in this case, we were using a tertiary amine surface coating. So a lot of really cool stuff we can do. This has applications for enhanced oil recovery, but also for carbon storage. If you inject the carbon dioxide as a foam, you actually get much better utilization of the pore space than you do otherwise. And then we currently have some ongoing work with an industry partner right now where we're using magnetic nanoparticles that we get to attach to the surface of oil droplets in produced water, and then we can remove them using a magnet. So this is a way of cleaning up that last little bit of oil that's in the produced water that you can't get at using gravity separation or centrifuging or anything like that. We've also looked at using these types of particles to remove things like lead and other heavy metals from water. So it's definitely got a lot of applications in these magnetic nanoparticles. Dr. Pradanovic and I have worked on these for several different applications, and they're really cool things. You can also get them to heat up if you expose them to an oscillating magnetic field. And so
magnets are fun and bubbles are fun. So when you put the two together, oh my.
That's right. What's not to like?
Right.
Yeah. And I actually want to show you all a video. This is us using these nanoparticles to separate. Let's see. I need to turn my pointer back to my pointer. Here we go. This is using the nanoparticles to separate oil and water. So you can see we're mixing oil and water over here. Now we're going to add some nanoparticles to it, and then we'll mix them a bit. I'm going to skip forward because this is a little long. All right, keep mixing. You're doing great. Okay, and then we turn on the pump and we run them through this magnetized battery of, this is steel wool that's in these tubes. And the magnetized steel wool picks up the oil droplets, and what comes out on the other end is clean water. And so we're able to remove like 99.7% of the oil droplets that are there. So it's pretty cool stuff. Okay, we also do some work with basic petrophysics. A lot of my work right now is focused on understanding gas flow in sediments. This has applications both for gas hydrates, but also for carbon sequestration. So we've done some, this is numerical simulations of, immiscible displacement. So understanding, the percolation properties and looking at, how fracturing happens in shallow marine sediments. But we also do things like with nuclear magnetic resonance. This is some fluid typing work. This is a method that we developed using a Gaussian clustering algorithm to take this two-dimensional NMR data and break it into different fluid populations. We also do work looking at micropores and shales. And this was a nuclear waste storage project that I worked on for a little bit. And finally, we are more recently getting into decarbonization. This is obviously a big and important area. And so I have, we've done work on looking at subsurface hydrogen storage. So all the different processes involved here, including microbial activity, the use of a cushion gas, different injection schemes, and then also some work that we're getting underway on carbon management. So understanding the entire kind of supply chain of CO2, when you capture it, you move it around, and then you sequester it somewhere. So how do we optimize that system as a whole engineered system? So I'm going to stop there, and I guess I'll let probably Dr. Ravikumar introduce his work, and then maybe we'll do some Q&A. So thank you all.
Okay, great. Thank you all for coming to this information session. I know, as Masha mentioned, it's all over the world in very different time zones. Some of you have probably already started your weekends, so I appreciate your time to learn about our graduate program and some of the research that we do. With that, I run the Sustainable Energy Transitions Lab at UT Austin. I am also the co-director of Energy Emissions Modeling and Data Lab. I'll talk a bit about some of the work we are doing through these initiatives. I am typically reachable by email, but you often get hundreds of emails a day, so it might take a while for me to respond to you. I am also reachable on social media, so I've had students reach out to me on Twitter to ask questions or to ask questions about the program or our research, and I more than welcome all of you making use of non-traditional channels of communication. All right, so our research is focused on thinking about the next 3 decades of oil and gas sustainability research. And this stems from my belief that addressing climate change is one of the world's most pressing challenges. but that it also presents a tremendous opportunity. And I think as a leader in oil and gas research, as you heard throughout this Zoom session, the UTPG department is uniquely positioned to be an academic leader in this energy transformation. And the fundamental challenge of the world right now is how do we go from our current world, which for the most part uses fossil fuels to meet its energy needs. By last count, around 80% of our energy needs come from fossil fuels, to a world that has net zero emissions by mid-century and beyond. So we know where we are right now. We know where we need to get to. What we don't know is how do we get there? And a lot of the work in my group starts thinking about what are the critical elements that you need to put in place to go from the left to the right. And so a key part of this is achieving success in addressing climate change now critically depends on accurately counting greenhouse gas emissions. And so for those of you who might not be familiar, the two major greenhouse gas emissions that are relevant here are carbon dioxide and methane. The carbon dioxide are things that are emitted when we combust fuels, coal, oil, and natural gas. And methane is majority of the natural gas that we use and is emitted across our oil and gas supply chains, but you also have other sources of methane emissions such as agriculture, natural sources such as wetlands and coal mines. So what our group does is sort of two things. The first half of our research is focused on measuring and modeling greenhouse gas emissions. So as you can see in the center image, we use a variety of technologies. We do a lot of field work. We go out to different parts of the country and sometimes the world to measure greenhouse gas emissions from various energy processes and energy systems. We use satellites, we use aircraft, we use drones, we use continuous sensors that are deployed all around the globe. And then we take all of the data from these advanced technologies and develop models and algorithms to interpret and understand what our emissions look like. And once we do that, we apply those insights in various application sectors. So we work very closely with the energy industry. We also work with government agencies in the US and around the world to think about how these measurements, what they tell us about our greenhouse gas emissions, and how do we then develop policies that are going to be effective in reducing them. We work with financial institutions such as banks, because banks are increasingly concerned about greenhouse gas emissions of their investment portfolios. And of course, a key part of it is also thinking about the future of technology, like how do we develop and improve technology and innovation to do this more cost effectively in the future. And the reason sort of accounting for carbon and greenhouse gas emissions is important is because a lot of decision making and policies around the world, whether it's carrots, such as tax credits and subsidies to reduce greenhouse gas emissions, or sticks, things like carbon taxes, emission standards. Almost every country in the world has one or multiple forms of these. All of these that are relevant to the energy sector are often based on availability of accurate greenhouse gas emissions estimates. So with that, what do we do? So the students in my group do sort of three things. The first one is we develop new science. We try and answer fundamental questions about greenhouse gas emissions from the energy sector, from the energy supply chain. So we go all the way from drilling and production activities. I have a few students right now in different parts of the country undertaking measurements, all the way through transmission and distribution and liquefaction. So we go to LNG terminals where we convert natural gas to a liquid form and ship it to various countries around the world. We then collect all of that data and generalize them into models and tools that can be used by the industry, used by civil society, as well as governments. And then we use insights from these models to build domestic and global policy recommendations, as well as capacity in doing these kinds of measurements all around the world. You know, we are only one team in the United States. We can only do so much. So we need to be able to replicate what we are doing here in other parts of the world. So we often work with universities in other countries to train them and to expand the network of measurements that are done around the world. All right, so some examples of the projects that students in my group are working on. So there are sort of broadly three categories of research topics and projects. The first one, as I already mentioned, we do a lot of field campaigns. You're looking at an image of a very large tank battery up in Canada, where we did some measurements. So we measure carbon dioxide and methane from the oil and gas supply chain. We go all the way from production through LNG terminals. Now we are starting to get into newer areas of measurements, such as for carbon capture and sequestration, hydrogen, as well as carbon removal. We then take all of the data and develop models to understand what's happening across the energy system, not any individual process. So we develop life cycle assessment tools for energy and energy intensive product supply chains, such as oil and gas, hydrogen, steel, etc. And then we bring in economics into this. We want to understand what are the cost effectiveness of various approaches to reduce and measure and monitor greenhouse gas emissions. So we develop techno-economic models to answer some of those questions. And so the important thing about thinking through the models and tools, as well as the next one, which is policy and analysis, is while the science happens at the micro level, at individual facilities, individual equipment, individual companies, the policies and decision-making often happen at the macro level, which is across the energy system, looking into interactions between different parts of our energy system. And so to do that, we take the data from our field campaigns, develop the models, and then using the insights from the models, we develop policy and analysis that are useful at the national scale or at the company level. So things like measurement, reporting, and verification protocols and policies for the US and around the world. We are currently doing this for the oil and gas sector, but we are increasingly looking at other sectors that are going to need these tools. And we develop assessments that are helpful for decision supports, whether it's in the industry or in government. Typically, students work on one of these three categories, but a PhD is 4 to 5 years, which means you can start with a project, going out in the field, collecting data, and then once you do that, you can switch to developing models based on the data you collected. So there's some level of flexibility in what kind of research that you're interested in and therefore would want to be doing as part of your graduate program. So what does it look like? So we have about 15 to 20 people in my group, of which 10 to 12 are graduate students, PhD and master's students. We have permanent research staff. These are folks already with PhDs and are leading some of these projects I talked about. And we have a few administrative staff as well. As you might have noticed, we do work that is highly collaborative and fast-paced. We often do projects where we have people from government, from the industry, from other universities, from non-governmental organizations that are involved. Usually projects are fairly large teams, so you'll get to talk to a wide variety of individuals outside UT Austin. And it's something we really work on nurturing, not just for your individual projects, but as a group, thinking through how do we solve this problem collectively and not as individuals in individual universities. All right, so here are just some images of the things we do. Some of our team members are in the photos that you see here. So we do a lot of field work. We develop these models, and then we make sure that the work that we do is useful to society. What that means is working closely with industry, engaging in the public policy process, both in the United States and elsewhere as needed. And it's important to note that not only do I do this, I make sure that all the students who work in my group also engage in all of these different types of communication and engagement with the broader world. With that, I'm going to stop and give you some resources. There are different ways to find more information about the work we do here at UT. The best ways to do it is talk to me or talk to current graduate students and researchers. There are a number of videos on YouTube that you can watch. You can read materials that I post on websites or follow me on social media. Of course, there are always papers that we publish that you can read and learn more about. But if you have more questions, feel free to reach out on by email, by social media, or other means if you like more information. With that, I'm going to turn it over to Masha.
One key difference between undergraduate and graduate work is the research part. So there's academic component and academic achievements as measured by courses and exams and so forth in both. However, undergraduate success is pretty much just academic achievement. And you might have some undergraduate research, but it's not mandatory for you to get a degree. Whereas most of graduate work requires some level of research to be actually successful. And that's kind of what Dr. Stegel and Ravi Kumar focused on. Here's a question in chat. Question on master's program and whether it's funding. We're going to get to the funding part, but I can briefly address it is a little less likely to get your master's program funded, but if you are going to do research, then yes. Essentially, the funding comes from individual grants that both Dr. Stegel and Ravi Kumar have mentioned. And in that sense, each faculty has a certain number of grants available and might need a certain number of students. And they look at the list of those students who are admitted and basically interview them and select a student. And of course, student has to be available too. So it's a bit of a matchmaking. Is that a game theory problem? That's a game theory problem. matching research grants essentially and the students available after they're recommended for admission.
Masha, there's a question.
Yes, I did mention, and you know what? It is unofficial because it got approved this week. So I think I possibly surprised Dr. Stegel and Ravi Kumar. It's been in the works. So we are a large institution. This institution is very formal too. So to approve a new degree, it takes typically on the order of 2 years because it has to go through all of the levels of approval. But yes, we do have Earth Energy Engineering Masters approved. Right now, it is actually a question whether you can apply for it directly in terms of the formal application, but you apply to this program and you will be able to do that master's if that's what you want. So yes. There will be a master's in Earth Energy Engineering. And because this approval process is so long, it's going to probably take us another 2 years to approve a formal PhD in Earth Energy Engineering. Is that a fair assessment, Dr. Daigle, on the administration and how long it takes?
Yeah, that's about right.
But that is
two-year lead time for everything.
I will also note, like, I'm throwing rocks on the administration and this and that, but there is something that is good about these checkpoints and I guess the breaks that universities sometimes puts on things, because then they're well thought through, and that is also what's the mark of the excellence of a university. So it's a love and hate relationship with rules. How is that? Yes, so I will actually, based on these questions, I can actually kind of move on, but I will invite Dr. Stegel and Ravi Kumar to estimate with some uncertainty in grant applications and some certainty in grant applications for those that you already have. How many open positions do you expect for fall 2025? Would you mind commenting on that?
Yes, I will be accepting about 3 to 4 graduate students. It may be a few more as well, depending on how, as Masha said, some of the grants turn out. But I do have 3 to 4 PhD student openings in my group.
Okay. Dr. Daigle, how about you?
I'll probably be looking for 1 or 2, depending on how things play out here.
Right. So 1 and 2 is common. So I can tell you that basically across our professoriate, most faculty are looking for 1 or 2 graduate students, and some of those are known now, and some of those will not be known until like February or March. Unfortunately, the way grants work, they don't care about the academic schedule. There is a grant schedule whenever you propose, and 6 months, typically 6 months after the proposal, you find out whether it was granted or not. And that comes throughout the year. So that's where the uncertainty comes from. There is a question for Dr. Ravi Kumar. Okay. Do you require experience in machine learning and data analysis in order to join your research lab?
No, I do not. In fact, I don't have experience in machine learning and data analysis. I am learning along with my students. I just need you to be interested in doing that kind of work and learning it as you're doing it.
I think I will comment on it more broadly as well. We do understand. So when you apply, you put forward your best application and the experience that you have. What we like seeing is that even when you don't have experience in something, there's evidence that you're always willing to learn. if that makes sense. So machine learning, as Dr. Ravi Kumar points out, a lot of us don't have formal training in machine learning. Well, it used to be called curve fitting, but in that sense, we don't have formal training, but we pick up new technologies, research as we go along. So yes, right now I actually do know something about machine learning, and I could teach some of it as well. But that wasn't the case 5 years ago. So openness to learning new stuff is one of the key marks of a successful researcher. Question for Dr. Daigle. You're holding bachelor's in petroleum engineering with research experience in publication in green hydrogen and electrochemical reduction. So I plan to apply for PhD directly. Are you working on those themes? So green hydrogen.
Yeah, so I'm not working on the kind of chemical conversion aspect of that. That might be better covered by somebody like Dr. Rakuno or Dr. Mohanty. I think they do some work on that. So you might check out what they're working on.
Again, the question is also like, are you willing to work on something and open yourself up to a new type of research? And to that, you also bring certain tools. So tools could be experiments, theory, modeling, or simulation, and data science or AI. So those are the 4 kind of pillars of any kind of scientific or engineering investigation. And what you should know is, what are you good at right now, and what are you willing to learn? My favorite joke is that I really love thinking about experiments. I collaborate with other faculty who do experimental work, and as a matter of fact, have an experimental lab. However, these 2 hands break things very often. So experiments are not my primary research tool, right? But I do understand that whenever I develop my simulation or modeling, I do have to actually take all into account and work on all areas. But there are certain primary tools that I use versus some other faculty might have different primary tools. Likewise, you should know that about yourself is experimental or modeling or AI or maybe policy. I don't know that we have policy as a research tool, but it's definitely something that is very important to our license to operate in society, right? So what are your interests and what are your strengths is something that you need to kind of know and think about and express that typically in the statement of purpose in the application. Yes, it is okay to apply without publication record. We do understand that. So if you do have publications or undergraduate research or research prior to applying, that is a plus, but it's not a requirement. So we do understand that people come from different institutions, and it's not that research depends on you some, but also the opportunities that you have at the home institution, and that might or might not be governed by you or directly in your command. So we do have that understanding. So you just, again, you put forward your best application, and then we go from there. Just before I close in this discussion, so this was pointed out already. So for research, when you are putting your application together, it is good to kind of do some basic research on what is out there, what the faculty do at the department. Do understand that you understand some of it and you cannot understand all of it, but in some general sense, you should be able to understand what does a group you're willing to work with work on. Web page. There's also UTPG YouTube webpage that links to faculty YouTube web pages. And on those YouTube web pages, there might be some teaching material as well as research presentation. Thanks to pandemic, I guess, is the fact that we have a lot of webinars that are now recorded and available online. And Center for Subsurface Energy and the Environment has regular webinars. So there's a library of webinars pretty much by anybody who is in the department. And you can go through that library and pick and for about an hour, see an overview of certain research areas that faculty are engaged in. We also give seminars at other departments. So if you do a good old search on the web, you can find recordings of those webinars. In terms of announcements of the available research, different faculty differ in terms of where they're active. I think both Professors Daigle and Ravi Kumar actively post both on YouTube and X and LinkedIn. Are you guys on LinkedIn?
Yeah.
There we go. So following their LinkedIn web pages is a good idea to follow their research, and that's typically true for individual faculty. I'm a little bit more reserved for LinkedIn. X is not my favorite type of expression. So you will find me on LinkedIn, and this is also where both myself as an associate chair and Dr. Balhoff as department chair post a lot of announcements in terms of the initiatives going on at the department. Our department, UT-PGE, has a LinkedIn page as well. Okay, so it is a good idea for like most up-to-date. So for instance, this presentation was announced on those pages as well as our department webpage. So that is where to go to find out more about research in the department. One thing that we're not focusing on, but we just want to point out, we are a large institution. We are pretty closely knit department. So we have a lot of other life going on, not just academic and research life. So we will have a mentoring group for first-year graduate students that you will be invited to join as you do, and we gather and discuss topics that are relevant to graduate students and their success in the program. We have multiple student organizations. That is a great way to network and also just find help and employ the entire team to help you through the graduate student journey. So SPE, Society of Petroleum Engineers, has a large group that is both undergraduate and graduate. PGSA is just a graduate student organization that is affiliated with our department. Drilling Engineers, SPWLA, Women in Petroleum Engineering, those are just some that are related to our department, but there's on School of Engineering level as well as university level, there is a graduate student organization that is pretty much in anything that you might be interested in, from academics to sports to various activities. And if not, then you are very welcome to start one on your own. Those groups also have their social media web pages, and if you follow them, you will get a good idea of what is going on in that area. So I invite you, for instance, to follow Instagram as well as Facebook for accounts for that type of activities. All right. Now, let me now get into, and please feel free to stop me with the questions as I go, but I think I'm going to now address a lot of questions that are popping up in the chat. So to apply, you will go to our to the link to the application that is linked to our graduate program webpage, and you can apply for master's or PhD in petroleum engineering, even if you're initially coming. So you can apply to direct PhD program, and if you're interested in pursuing PhD, yes, do so immediately. Okay. Otherwise, you can say I'm applying to master's only, or you say master's now with the intent to do PhD. So it will ask you, what is your terminal degree intent? And that tells us that even if you're starting with master's, you're interested in PhD. The speed of either depends. I can go into the requirements a little bit, but if you're doing master's first, you're going to complete a report or a thesis, which is master's thesis, before you proceed to PhD formally. If you do have an intent to do PhD, ultimately do express that immediately in your application, because it does tell us then how many years you plan to stay in the department, and that does matter. Now, masters can be non-research and just coursework. However, in that case, you are expected to have your funding entirely if you're doing only coursework. The funding that comes is typically from various faculty is to pursue research. Now, deadlines are December 15th, which I hope everybody on the call knows the deadline for the fall. We're now talking about fall 2025 and September 1st for spring semester. You need to complete the application form and pay the fee, and you will need your official college transcripts. Sometimes those take a little longer to actually receive from the university. So please, and you will need those ultimately, but if you have your own copy, even if it's unofficial copy, upload it, just so that we have that copy until we're waiting for the official one. Just a good practice to do. You will put together your resume. Resume format is not prescribed, but it should be, you know, legible, orderly, and have all of the relevant information. So I would put, there is no need to limit it to one page, so it can be a longer resume. Academic resumes are not short. So in that sense, feel free to put all of your relevant experience and outline it on the resume. You will be prompted to fill out a statement of purpose or essay. Basically, there is 2 essay questions where you are basically stating where you're coming from, what is your background, what is your interest and motivation to pursue graduate school. If you do have faculty that you'd like to work with, this is where you can point that out, but it is not binding. Okay, so we do understand that everybody comes in and know you're not supposed to know everything, and you might not be aware of certain research opportunities that are out there. So it just gives us an idea of what you would like to work on, but it is not binding in any way. So do some research and tell us what your interests are, but understand that it's not a must to follow what you put in your statement of purpose. You will also need to identify 3 people who will provide your recommendation. Those are supposed to be technical recommendations. So somebody who knows either your academic or research work, somebody from university, or maybe you have done an internship and participated in some sort of an industry effort. In that case, those are technical recommendations as well, but they should speak about your technical achievements. GRE test, there was a question about GRE test. Yes, we do require GRE, and we do not waive GRE pretty much in any, there's no circumstance under which we actually waive GRE. There was a temporary waive during the pandemic, but that was because a lot of testing centers were closed and it was hard to take it. Okay? So why do we do that? Your academic performance, your official college transcript, and the grade point average on their GPA is one way to describe you. GRE test, but it's different around the world. There are different institutions, and they have different types of programs. In terms of GRE, it is kind of a uniform test that is applied in the same way to everybody. So we need that as a data point. We do understand that it is an expense, so we are keenly aware of that, but at the same time, for us to evaluate all of the applications that are coming our way, GRE is a helpful data point. There is no such thing as a minimum requirement on a GRE. It's also a test that can be retaken. However, you can actually post on our website. There are averages that are posted, and all we can speak about is averages. We don't hold ourselves to any specific threshold minimum. So that's just something for you to know. And then if you're coming from an international program, we need English proficiency test. Either a test of English as a TOEFL or IELTS, either can be supplied for that. That we don't differentiate. And again, we do not waive these tests because we need to be fair to all of the applications that are evaluated at the university. We are held to the fairness standard. This master's program is, again, it's been in the works. It's going to be implemented in fall 2025. Right now, we don't have it formally on the application because it was literally moved through the process last week. However, I will also like to point out that courses that are going to be covered in this program, which are both fundamental of petroleum engineering and geoscience, as well as the new content in renewable energy sources, have been taught in our department for a while. So honestly, the courses that are actually part of it are not new, because we've had them taught for a while. So for instance, we have a standing course in geothermal energy, carbon capture and storage, methane emissions, hydrogen storage is coming up, part of the natural gas storage. We do a lot of research in remediation of water, and so forth. So in that sense, we have had the coursework in place for a while. We just haven't had the program approved. So as you come in, you will be able to find out how to formally take this Masters of Science in EEE, as it were, Earth Energy Engineering. Okay. So funding and support is another large question. So let me just pause here and describe the process once again, and then I will actually ask you if you have any further questions on the topic. So when your applications come in, by whatever the deadline is, we have a committee. I'm the chair of the committee that reviews all of the applications at hand. There was a question is, should I contact faculty in advance? The answer to that is yes, you can. However, don't take it personally if faculty doesn't respond. The average number of emails in my inbox per day is 70 to 100, and I'm probably an average in our department. And there are people with more emails and less emails. So in that sense, it is extremely hard to follow through on all of the email correspondence. At the end of the day, I have to be here in a presentation or teach or do other things as well. And the time for responding to emails is somewhat limited. With that understanding, you are welcome to introduce yourself. And sometimes even if we don't respond, we do kind of pay attention to what comes in, okay? So that said, the way we function is not by a direct contact to a faculty member, because you have to be recommended for admissions first. And that's basically maintaining the fairness and similar level across the department in terms of academic performance. So basically the committee will review applications and recommend them for admission. And there's a list of students that is recommended for admission. And that goes back to faculty. From that list, at that time, if you get an email, hey, you have been admitted to the department, but at this point, we don't have funding. That's what it means. You have been recommended, and your name, assuming that you don't have a funding on your own, your name has been forwarded to the faculty. At that time is the best actually to contact faculty and say, hey, I have been admitted by UT PGE. Do you have any research opportunities available? Okay? And at that point, faculty will be interviewing for the positions that they have. When I said that it was a game theory, it's an application process where there is parties that have positions and parties that would like those positions, and they also have to form a relationship and like each other in order to enter a contract. It's kind of normal, but it's actually helpful still to point that out. So in that sense, a faculty may make an offer, say that I have a position and I make one offer. My offer to somebody is binding, and when it's out there, until it's accepted or denied, I might not make another offer. I'm going to repeat that. So if I have one position and I make an offer and it's open to a student to respond to, until a student responds, I don't know whether I have that position open or closed, and I have to wait for that response. So sometimes when response doesn't come back your way, that means that the faculty member is uncertain whether they, this very moment, have an open position. So say that the student responds and say, no, I want to work with Dr. Ravikumar. Okay? Then I might have that position open again. So there's a little bit of a dynamic nature to this because the positions are not, it's not a fixed pool. It's a fixed number of offers that we can make, and they are financially binding. So I cannot put out there 5 offers and see if all 5 get accepted, I'm in financial trouble. And budgets are finite. So with that said, this process still works out quite well, and we have 70% of students who are supported by research grants or department. They're the ones that are actually you're made an offer. And if you are made an offer by a faculty member, then it's a form of what we call GRA/TA, graduate mix of research and teaching duties within a research group. Current salary is $34,000, give or take, per year for 12 months. Typically, that goes up at least 2 to 5% every year, but that has not been determined yet for the next year. So this is the number that we have for this year. In addition to that, there are some benefits such as health insurance that are involved with it, and faculty member also pays tuition. Again, there are grants that cover both tuition and salary, and the total package with all of the benefits is over $50,000. So in essence, for a faculty member to cover a student, they have to have on the order of $50,000 somewhere in accounts to cover that. Yes, so I'd like you to understand that. And more depending on the grant, but that's too much detail for you to know. But you should know that there's a amount that needs to exist in budgets for that. About additional 15% of the students have support by foreign governments. Now that depends on the countries around the world. As well as individual companies. So some example is Petrobras or certain Thailand companies or Saudi Aramco or so forth. They provide funding for their employees to come and study at the University of Texas. And then there are some limited fellowships. Those are the ones that students can apply for individually. We are not in control of those, but for instance, Fulbright scholars are relatively common. We have 2 to 3 in our program at all time. And they're country and region dependent. And again, we don't control them, but we support them if they come in to our department. For instance, for 26, at this point, the award cycle for full 2025 is closed, but in April 2025, they will open a cycle for 2026, 2027. That's what I found out on US Fulbright website. Other Fulbright websites from different parts of the world might be slightly different. US Department of Energy, this is for US citizens and permanent residents. They have applications due in January 2025. Again, we can help out in students applying for them, but we don't control them. It's the US Department of Energy that is controlling them. Those are 2 examples. There might be more out there, but those are the individual applications from students as opposed to us. Some students are self-supported. That is a very small number on the order of 2 to 3 out of the entire pool of students. And then we have a whole bunch of, and they're outlined in a different color. They're what we call topper scholarships. So there is a range of scholarships that are from donations to the university as well as university endowments. And on average, they can have really varied amounts that depend on the donor. However, on average, they're about $3,000 per year, and all students are considered for them automatically. So they're topper in the sense that the amount, $3,000 per year, is not enough to sustain anybody for a year. It's just additional amount on top of what one should have as a tier, a salary or something to cover living expenses. So those are the general pools of funding and support that we have available. I'm going to stop here and ask if there are any questions. And you can either unmute yourself or put a question in the chat. So there's a GRE question. So GRE, here's how GRE works. If there are sometimes issues with getting the date or date of the test by the deadline, you should put in your application by deadline. And if GRE is coming within a month or so, that is typically okay. Does that answer your question? So it can be, and sometimes also GRE is a little late in sending their data or data being processed on the university side. This is again because we are a large university and everything is coming to the graduate school, not departments individually. And that's a large number for a university of this size. So we are actually accustomed to waiting for GRE. Yeah. That said, I do have to have that number to review your application. So GRE can come in slightly after the application deadline. If it's very late after the deadline, that does affect your application in the sense that you might not be reviewed in time with all others. And that's the best we can do. Okay. So yeah, and if you have taken your GRE, there's a way for you to self-report in the application that you did it. Please do so. Again, for the reason that the GRE's official GRE scores that we do need to have before we process everything, but we can take that self-reported number into account before the official one comes. So whatever information you have, supply it yourself, and then we will wait for the official channels to come through as well. Percolate as they may. And I think I noted already official transcripts. If you have unofficial copy from you, put it in, and then let the official one percolate as it does. Sometimes takes longer.
Yes, please. I just wanted to inquire about one of the requirements, the English proficiency requirements for application,
Yes.
right? So
Yes.
So my first and second degree are from Nigeria, all English taught. Do I still need to show the proficiency? Can it be waived?
I think so. So the only waive is for US institution and possibly Canadian, unfortunately. So I do understand that you took your entire university education in English, but you do still have to do test of English as a second language. If that one comes in later, that's fine.
Okay, but
so that one can be delayed. It's the key thing to have for us to review is to have a GRE.
Okay.
So to have a GRE, test of English as a second language can come in later. Yes, we do understand that a lot of schools in Nigeria teach in English. Does that help?
So, okay, that's okay. But do you mean it can come after the admission?
Yes, TOEFL can come in after the admission, yes.
Okay. All right, thank you.
So I have just a few slides. I actually don't want to belabor on these details. These are details that are important once you come in, but I'd just like you to get some idea about the types of programs. So if you have a master's, and this is master's in PE, but the EEE, the new program, will follow similar format. So for masters, we have options that are thesis, report, PhD fast track, and no thesis, no report. So the difference between the two is if you take a thesis, then the number of this is essentially equivalent to 8 courses. The number of courses is the least number of courses because you're writing a more sizable thesis, right? So report is less of an extent in terms of research done. So you do need to take more courses. So that's 30 hours. That's basically 10 courses. And then the similar thing is that if you're on a PhD fast track, and the difference between master's report version or PhD fast track is that on PhD fast track, you do have to take a qualifying exam for PhD immediately when you enter the program. And then no thesis, no report is just coursework that is 12 courses. So those are the options for the masters. And we do have some requirements which will be evaluated as you come in by a graduate advisor. We are giving a degree. in either petroleum engineering or earth energy engineering. So you're supposed to have certain background requirements. My original degree is in applied math. So if you come for applied math, which I didn't do PhD in Austin, but if I did come in through our department, I would actually have to take basic courses as required by a petroleum engineering program in order to get a degree in petroleum engineering. So that's somewhat understandable, but then the coursework would be maybe possibly dominated by those requirements. If you're already a petroleum engineering major, then you don't need all of those requirements and you can proceed and take a lot of courses. We do teach a lot of courses. We're actually proud of that in terms of teaching a variety of courses. I think we're one of the top programs out there because we do have a sizable faculty and the various courses that we organize. So I'm not going to go through the modules and options in detail. That's again something that is typically worked out when you get here. But here it's in the slides if anybody's interested or wants to ask a question. But we do have a structured way of which type of courses you're required to take so that you get a very broad education. And we are actually proud of that because then the academic excellence is maintained for people who hold a degree from our department. And then just again, one more point that I'm going to make about this slide is that if you are on a PhD track, you will take qualifying exam and start working through PhD requirements immediately, as opposed to doing and completing masters first before you either complete or proceed to PhD. So in that sense, PhD requires passing a qualifying exam, which right now you will take coursework and you need to have certain level of performance in that coursework. So good grades in that coursework. And you're supposed to take that either in the first or second semester, depending how courses are offered. You will declare which 3 courses, there is a range of courses you can choose from, which 3 you're going to take as part of your qualifying exam. After that is completed, you will start working on your research topic and do a literature review and basically go through the academic program as you do all of this. And there will be an oral proposal exam where you will have a written proposal in terms of the research literature review, as well as what is your research plan. And this is at this point, you will assemble a committee of 5 professors, 4 of them from PGE and 1 external that will be evaluating you also at your defense. Once you pass that proposal exam, meaning that committee agrees that your research plan is sound, and also you might be answering some fundamental questions about coursework related to those, that oral proposal, then you advance to candidacy and you're called PhD candidate, and you work mostly on your research at that point. Here and there, maybe take an additional course until you do a final defense and graduate, and then after that is job placement. If you have questions about all of the nitty-gritty details about the degree requirements, they can be found on this website. You will follow on the website, you will follow this degree requirements tab, and there you can find what we call graduate student handbook with all of the details. Okay. And with that, further ado, I will ask if there are, I'm ready to close the information part, but I'm here to answer any further questions you might have.
Thank you very much for a great presentation, Dr. Pradanovic. Just a quick question regarding the qualifying exam. So you mentioned that they will be like specific subjects, if I'm not mistaken, like
yes,
thermodynamics, petrophysics, etc., or the subjects change, or
there's
it's the same?
So right now there is 6 courses that you could take. So basically there is transport phenomena, advanced petrophysics, engineering analysis, subsurface machine learning, geomechanics, and thermodynamics.
Okay. And
So those are 6 options. So say that you come in so this is the current rules, and I'm saying current rules because they do slightly change. We keep arguing what is the best way to do those things as faculty. This is faculty fun, and we do actually adjust as we go. So right now, this is these 6. So say you come in, if you came in fall 2024, you would find that first 3, engineering analysis, transport, and petrophysics, are actually offered in fall. But
Okay.
subsurface machine learning, geomechanics, and thermodynamics are offered in spring. So by October or so, you have to tell the department which 3. So, and you can't change once you say which 3. So if all 3 are in fall, then by the end of fall, you might be done. But if, say, you want to do transport, petrophysics, and geomechanics
Right.
as options, then you will be done in May.
Okay. Yeah,
And
because
that's,
in my master's, like here in Canada, I've taken the advanced thermodynamics, like vapor liquid equilibrium and transport phenomena as well. So would it matter if I take it again or I don't take them? Does it have any relevance?
so you could then choose to take a different course, but it's not that, then that other course has to count as your qualifying. We do need a grade from our own course right now in the current program.
Got it. Yeah. Thank
We
you very much.
are arguing about it. It might actually, and that's why I'm pointing out, it might change for fall 2025, because we used to have, so we have right now 3 proposals that might actually just have an additional exam and not be related to
Right.
specifically taking coursework.
Makes sense. Thank you.
So, and again, it's a constant source of push and pull around, like, what do we think is best? And I think the answer is that there's no best way to test, right? So,
That's true, yeah.
that's the reality, right? Tests are limited at the end of the day. Your ultimate test is your PhD defense. How's that? So there's also a question on my PhD position. So I'm in this class of faculty that is right now, I don't have an open position, but I have 2 open applications out there to various agencies, which I will hopefully know by January whether I have a position. Sorry, I'm I'm in fundamental processes. My research is a little bit less applied, which also means that my group is a little smaller than the average. That's just my reality, but I love my basic research and I'm sticking to it. Dr. Arvind. Arvind, are you still on the call? Dr. Arvind might have slipped off. I will answer for him. So he said that he is going to have 3 to 4 positions available, I believe. Whether it's an open master's position, again, we do prefer students who intend to do PhD, simply because research doesn't really finish, and 2 years of typical master's is relatively short for research. So if you do have an intent to stay for a PhD, please say so. But that said, we often pick up students that are doing masters first and then stay for PhD, or maybe complete masters and go away. It's just a little less funding available for just master students. Oh, there's a question on waiver. Unfortunately, we don't have official waivers. I will double check again, but as a this is related to budgets again. We don't have, the university does not waive application fee under no circumstances. It is, we do understand that a lot of people have financial need, especially when coming from internationally, because the way conversions work, the amount of fee scales differently based on whether you're in the United States or outside. But that said, we don't have a fixed budget for waivers, and we cannot simply waive it for everybody because, again, we don't have that budget. So it's extremely hard for us to also then decide how to waive, how not to waive. There is a fairness question. We cannot waive for somebody and not for somebody else. And because there is no existing budget for waivers, that's where that problem comes in. So I apologize. I know that it is a fee, but right now it's standing. Oh, at what point? So right now, so there's a question on what point can you update unofficial with official? At any point, really. So right now you might have unofficial. If unofficial transcript is everything that you have, you just put that in, and sometimes again, and that doesn't necessarily always depend on you, official is taking a little bit more. So as long as we have unofficial transcript available, we will proceed with what you have, and then you will have to update it come January. So it can be your official update can be a week or two late, or a month or two even late. Ultimately, your ultimate point of where you have to have official transcript, and also that you graduated, because right now you might have not graduated from the university, is basically admission to the university. So you will not be able to enroll unless the university holds official transcript from your institution, that comes from your institution, not just from you. So there's another question. Yes, you can apply to multiple departments. However, I don't see any application that is not PGE application. So yes, you can apply to different but those are separate applications. So there is a question also, if there is a master's in earth energy and resources, that is in geosciences department. So yes, you can apply for it, but it's a separate application that is looked at separately. So you take the same GRE or same tests that you supply to different applications. However, I do not look at any applications. I don't have an appointment in geosciences department. I have colleagues I work with, but I cannot see their applications, nor do I participate in that selection. So each department does their own selection and processing of the graduate applications. Oh, you got me there. Does one application fee cover applications to multiple programs? I don't know. So I'm not going to answer that. It might be that you might need to pay separate application fees. I don't know. I haven't tried, I guess, applying to different departments. Oh, there are many PhD programs. Are there any other PhD programs apart from those presented today? I cannot invite entire faculty to present because we would be here all day. So I basically, whenever we have graduate program review, I invite one or two faculty to present. And today the chips fell on Dr. Stegel and Ravi Kumar. So yes, all of the departments, so let me show. We have a lot of faculty. I'm going to show the list. This is the list of faculty. The ones that are inactive, they're emeriti, are Professor Gray, Professor Bomer. Professor Lake is in a process of phased retirement, though he still co-advises students. Professor Pope is emeritus. And Mary Wheeler has just retired this year. So those are the professors who don't necessarily have active research programs, or they're winding their programs down. Everybody else has a research program, and how many positions they will have in fall, again, depends. Most of the time, one at least, but maybe up to 3 or 4, as Dr. Ravi Kumar pointed out. So all of these faculty can be individually. Oh, I'm sorry, Dr. Olson, Hillary Olson is a teaching faculty. So you can contact everybody, and all of them, if they have a position, will look at the applicants recommended for admission. Again, this is a large number here, so I cannot have everybody present during this. All right. Well, with that, thank you very much for your time and attention. I will post this recording on YouTube so you can get back to it, or if you know somebody who needs this information, they can go to our YouTube webpage. I will also post a link on my LinkedIn when it's available, so that way it should be fairly well broadcast, though I do understand it's not perfect. Thank you very much. Nice to meet you, and I'm looking forward to reviewing your application come December.